So I think we can start. So hello everyone. First, I'd like to welcome you all to another session of DHC webinars. This session is titled as Classifying a Large Collection of English Poetry Using Semantic and Prosodic Features by Dr. Shank. He's an assistant professor at the School of Information Science and Learning Technologies at the University of Missouri, US. He has received his PhD in Information Sciences from the University of Illinois Urbana-Champaign, again in the US, and his bachelor's degree from Peking University in China. His research focuses on digital humanities, exploring scholarly inquiries on history and literature through computational methods. And this session lasts around 45 minutes. So without further ado, I'd like to welcome Dr. Shan to the virtual stage. Thank you.
Thank you very much, Maxat, for the introduction and also for inviting me to this wonderful event. And I haven't been to Iran in person, but I have long been impressed by the city of Shiraz as a city of known as a city of poetry and flower, and also the hometown of the great poets Sadi and Shafez. So making it a perfect. Making it a perfect destination for me to give the presentation about poetry today. So
great.
Much appreciated. And so I'll begin my presentation. All right. So it seems that I probably need to present in this mode rather than the switching it into the full screen so that you can see where I'm at. Okay. So my presentation today will be classifying a large collection of English poetry using semantic and prosodic features. And so first of all, I'm going to introduce the content, including a brief introduction of how can digital methods contribute to literary studies. So not only for this project, but also my understanding on the role of digital humanities in the larger scope of literary studies, or actually for the humanities studies in general. And then we introduce this particular project, including the background of the poetry classification project, its methods, results, and conclusion, both for this particular project and for the overall landscape. Oops, look, I stopped sharing. Okay, so first, introduction. How can digital methods contribute to literary studies? I'll begin with this story. So the street light effect. So on one occasion, a neighbor found him Nasruddin down on his knees looking for something. What have you lost, Mullah? My key, said Nasruddin. After a few minutes of searching, the other man asked, where did you drop it? At home. Then why, for heaven's sake, are you looking here? There's more light here. So this story was popularized in the Western context after that. So known as the figure in the right, that's a person in the right that looking is a drunkard. That's called drunkard effect. That's a person who is drunk, look for the key, although he lost his key in the park, but he looked for the key under the street light. And so it is a metaphor to describe that people looking for something where there is evidence available rather than there's a problem or meaningful question there. So, but this could be this is called the observational bias in the social sciences. So where researchers focus on questions for which evidence is readily available, rather than there will be meaningful questions. It is equally relevant to the humanities, since scholars are restricted to proposing questions and interpreting these results based on the materials they can directly comprehend. The scale of which is limited because one person has a limited knowledge and he cannot comprehend the entire materials that those questions lay, and must be restricted to the materials that the person is able to comprehend. But the arrival of the information age has a potential to transform this landscape with the help of the exploding amount of digitized sources, and also the application of computational methods in the humanities research. Both provide new light to illuminate areas previously shrouded in darkness. So it doesn't mean that we are able to investigate the new questions that are no evidence available, we're still limited to our evidence. But with the digitized data, there are more such evidence. And with the computational methods, we have the new capabilities to investigate a larger scope of materials together. So this is why this is called the digital humanities and why it could change the landscape. However, there are a lot of criticisms for the digital humanities in dealing with humanities methods. So I'm going to quote Nanda, who is a professor in English at Johns Hopkins. She argued that in her work, the computational case against computational literary studies, in these other sectors where we are truly dealing with large, the purposeful reduction of features like nuance, lexical variance, and grammatical complexity is desirable for that industry standards and goals. In literary studies, there's no rationale for such reductionism. In fact, the discipline is about reducing reductionism. So her point was actually that in some sectors, like when you are trying to deal with large, like when analyzing the user's review for market purpose, it's fine to reduce such nuances into something more simple, can be simplified and can be analyzed altogether in a large scope. But she argued that in literary studies, it's quite different because the discipline is about reducing reductionism. We cannot reduce the nuances for another purpose because what matters actually is the nuances in literary studies. So she argued we may not use computation methods because it will cause a loss in the thing that really matters. So according to her and many other critics of digital humanities, science or natural sciences seek singular answers, but the humanities, especially literary studies, looks for the perspectival and interpretive nuances. And the subtlety of the text and the cultural particularity of the context could be easily lost in macro level or distant analysis. So in our metaphor that while the new streetlight could light more spaces, it is the nuances and interpreting nuances that matters will last in such process. So we may not use digital humanities. But my point today is that we can use computational methods as interpretive tools. So I'm going to quote the famous French literary critic Roland Barthes in his famous work, The Death of the Author. So he argued that we know now that a text is not a line of words releasing a single theological message or the message of the author God, but a multi-dimensional space in which a variety of writings, none of them original, blend, and clash. So this is a very famous quotation. And for traditional literary critics, this is not talking about digital methods at all, but for any text. So he argued that we may not necessarily need to understand the meaning of the author or the author God in his words, but we may try to analyze it from a certain perspective because it's a multi-dimensional space in which a variety of writings, none of them original, blend, and clash. That's how we approach literary theory from a literary work from a theoretical perspective. And I argue that this is exactly where computational methods can come in, because we can approach the text from a unique dimension. According to Mark Orson, computers can be used to isolate and examine the symbolic universe in which an author writes. And that's actually what computational methods is particularly capable of. So rather than investigating certain objective thing, which is not the goal of humanities, of the discipline of literary studies, we can use computers not to analyze the objective perspective, but analyze a certain subjective perspective. And the computer is actually good at this because we can use computer to analyze a particular perspective and that particular perspective only, and we can isolate and examine the entire literary work to that particular perspective, which could gain insights into the literary work, which is exactly the traditional literary critiques done with non-computational method. But with the help of computers, I'm going to showcase that how we can approach it with a better capacity. And we can move from microscopic to macroscopic. So according to Laura Putnam in the transnational and the text searchable, she argued that text searchable sources make it possible to trace individual people or sounds, pamphlets, phrases, allowing us to observe at a micro level the process that generates aggregate macro level flows and connections. So she's a historian. She was talking about analyzing the historical materials, the sources, the documents in a much larger scope. But this is equally relevant to the literary studies. So we can analyze the micro level, for example, individual literary works, or in our case, poems. And when we analyze thousands or millions of them in the aggregate, we can observe the macro level flows and connections. And here, essentially, we are analyzing from a certain perspective of the entire large corpus. We try to analyze a certain perspective, certain characteristics of the micro level objects, like poems, and then we can try to use these poems to this aggregation of large number of poems and large number of individual characteristics to analyze the macro level flows and connections and the bigger picture in literary history. So once again, we are analyzing not something objective, but something from a certain perspective of the subjective characteristics in the poetry or in literary studies in general. So in this talk, I'm going to introduce a project that offers new insights into the macroscopic trends that literary studies at the individual or microscopic scale often fail to review. I'm going to classify around 40,000 English poetry by lexicon and prosody using machine learning models. So rather than compare to the traditional method that may approach this problem by analyzing like 5 or 10 individual poems, we try to analyze a large number of poems together. But rather than try to reach a conclusion that is objective, like the science, but we are going to analyze something try to analyze something interpretive to ask how this could contribute to the literary scholarly discourse. So now let's jump to the particular project, the poetry classification project. So first, background. So the motivation that drove this particular project is that the boundary between the genre and the form in literary studies is ambiguous, and they are often used interchangeably. So scholars associated with the new formalism are criticized for perceiving everything as a form. So they would argue that you can imagine that many poetic category, like I'm going to discuss like the sonnets, the ballads, heroic couplets, and many will call everything as a form, but digital humanists tend to argue that everything is a genre. So the terms forms, genre, and maybe others formats are used quite interchangeably. There's no clear boundary between these terms. And we're going to try how computational models can provide a fresh perspective on this long debated relationship, especially for the poetic text, where semantic and prosodic features are to some extent separable. I'm going to explain that later. And the previous studies find that there's a semantic halo of the meter, that is, the poems that are using similar meters tend to have similar words used, similar lexicons used in these poems. So basically that there's a relationship between the structural elements of the poems, like what meter they're using and what words they're using, the semantic things. So I'm going to approach this problem from a from an opposite perspective, rather than discuss how the poems, the forms and the meters of the prosodics and the semantics, lexicon used, how are they related? I'm going to investigate how are they separable? So how we can disentangle these different things by using machine learning models in the classification. So I propose two research questions. So first, what poetry categories have a stronger semantic character, and which ones have a stronger prosodic characters? That we know that we're just let's just call it categories to avoid defining the genres and forms in the first place. Let's say there are many categories like sonnets, ballads, and I'm going to ask that which ones have a stronger, when we will say a poem is a sonnet, do we say it based on the words they're using, or based on the you can imagine for something could easily be the later case, or the format they're using, the meters and rhymes they're using. And to analyze multiple poetic categories, we're going to say which ones are semantic and which ones are prosodic. And the second question, is there a clear division between categories that are more driven by semantic features and those more driven by prosodic features? So let's say if we can say that some categories are mostly defined by the form they're using, and others by the words, the lexicon they're using. Then I'm going to ask that is there a clear division? Is that the case that some points are clearly defined by one, and some categories are clearly defined by the other? Or it's rather not the case, or each poetic category has both semantic and prosodic features. So is there clear divisions between these categories? So we're going to address this question by classifying various categories of English poetry using lexicons related to semantics and also prosodics, including meters and rhymes. We're going to define them separately. We're going to classify them separately and ask how the relative importance of semantic and prosodic features vary across different categories. So I'm going to explain the methods we used in the experiment. So in data collection, we collected a total collection of around more than 37,000 English poems tagged with a specific at genre from the Chadwick-Haley literary collection. So the ATT genre is something defined by the Chadwick-Haley literary collections, and we just call it category here because it could be anything, and like ballet, song, and so on and so forth. And then since there are many of the 44 total categories only have a few cases, so we only collect the top 27 categories with at least 100 cases, consisting actually a vast majority of the poems, over 97% of the poems. And then we extract the features for both the prosodic features and the lexical, the semantic features. For the semantic features, we extract the lexicons, basically what words they're using in each poem, by transforming the text into an array of word frequencies. So you can imagine that for each poem, there will be a large array of like the word A, how many times the word A is used in the poem, and how many times the word B is used in the poems, and so on and so forth, after removing the stop words. And for the prosodic features, we extract 3 prosodic features, including foot type, that is such like the strong and weak syllables, like the iambic, choice, dactyl, so on and so forth, and feet number, that how many feet are there in each poem. Like if there are 5 feet in each line, then we call it pentameter. If there are 4 of them, then we call it tetrameter, and so on and so forth. And also the rhyme scheme, like if the scheme is ABAB, that it will be alternate rhyme. If it's ABBA, it will be an embedded rhyme, and so on and so forth. And using the poetry library policy, Python library policy. So this is created by the Stanford Literary Lab, and it is not without debate. But there's have a complicated issue. They have a complicated process of extracting this information, and we just rely on their judgment in this project. And we then trained machine learning classifiers. So we conducted a grid search to select the algorithm and the number of features used for classification. So by conducting a grid search, we try to use like multiple classifier, like the multiple algorithms, like the random forest algorithm, SVM, perceptron, so on and so forth, the most commonly used machine learning classifiers. And then also we try to go through for the semantic classifier, we go through different number of words, like we select top 500 words, top 1,000 words, top 2,000 words, and so on and so forth, and see which ones achieve as the best performance for our sample size. Then we use it to classify the entire data set. And we find that random forest algorithm and the top 1,000 words to be most ideal for the semantic classifier, and the random forest algorithm to be most ideal for the prosodic classifier. And then we conduct the classification experiments. So we conduct 2 experiments. So first, we compare the performances of the 2 classifiers on a 27 category classification task. So we ask the classifier trained on the words they're using the semantic classifier to assign each poem into one of the 27 categories. So we ask it to assign into either sonnets or ballads or heroic couplets and so on and so forth. And then we ask the prosodic classifier to do the same. And then we also try to conduct 27 two-category classification tasks, like we ask the semantic classifier to classify a poem to be sonnets or non-sonnets. So in this case, there are no 27 candidates, but only 2. But we repeat it for 27 times. So each time ask it to be sonnets or non-sonnets, ballads or non-ballads, so on and so forth. And then the classification experiments, we compare the performance of the two classifiers on a 27 category classification task and the 27, Then we, after that, we use Hartinger's deep test to test whether distribution of the differences in accuracy is the uni model. I'm going to explain this in more detail later, but basically the point is that, so for each of the 27 category classification tasks, we're going to achieve an accuracy for the semantic classifier. Let's say we have for the semantic classifier achieve 80% accuracy in classifying sonnets, and 75%, and the prosodic classifier achieved a 75% accuracy in classifying sonnets. Then we subtract the 80% with the 75%, we have the result will be 5%. That means that for the sonnets, is better classified by the prosodic features, by the semantic features, and they are 5% better in that. Then we have a number of the difference for each of the 27 categories. Then we have a distribution of how the difference is distributed across the 27 categories. And then we're going to test whether this is a uni-model distribution or not. And then finally, we'll analyze the classifier performance of poems authored by different poets using the holdout one strategy, meaning that we're going to train the classifier use all poets other than the one poet to be investigated, and then classify the poems of that poet based on the others, so that the classifier will not see this poet's particular patterns, but based on others to see how they can be classified. And then we move to the results. So for the 27 classification experiment, we can show that you can see the confusion matrices of the semantic classifier in the left and the prosodic classifier in the right. So we can see that overall, you can see that from the top, that the two classifiers have a similar overall performance. For the semantic classifier, we have accuracy of 0.58. And for the prosodic classifier, we have accuracy of 0.56. So that's almost basically the same. However, the results on different categories significantly differ. So we can see that it's very obvious from the confusion matrices. So from the left, we can see that semantic classifier classifies the ballads and metrical sums very well with 90% and 91%, with 90% accuracy each. But it easily confuses heroic couplets. You can see that from the third line, the third row and third column, that we can confuse the heroic couplets with sonnets and epigrams. So it means that 38% of the heroic couplets are wrongly classified as sonnets, and 36 of epigrams are wrongly classified as heroic couplets. On the other hand, the prosodic classifiers performs well in classifying heroic couplets. That is where the semantic classifier struggles. However, it struggles with differentiating ballads. You can see that from the fourth row and the fourth column with and metrical sums, it classifies 20% of ballads into lyrics and 22% of metrical sums into ballads. So that's the fourth row and fourth column. So you can see that what the prosodic classifier does very well, these categories can be misclassified a lot by the semantic classifier and vice versa. So that the overall performance of the two classifiers are quite similar, but they have very different performance on specific poetic categories. This is further verified by the two category classification experiments. So this figure is the performance of the semantic prosodic classifier on the two category classifications. So the x-axis is the semantic accuracy, that is how well the semantic classifier can classify each poetic category, and the y-axis is how the prosodic classifier can classify each poetic category, and the red line is that the semantic accuracy equals to prosodic accuracy. So that's the poetic categories that above the line means that they can be better classified by the prosodic features, and the ones that below the line means that they can be better classified by the semantic features. So once again, 5 categories: sonnets, heroic couplets, concrete poem, haiku, and limerick are better distinguished when classified by the prosodic classifier, while all other 22 categories display superior distinction when classified by the semantic classifier. So in other words, most categories have a stronger semantic character, but as categories such as sonnets, heroic couplets, concrete poems, and haiku have a stronger prosodic character. So different categories. This confirms to our first question that different poetic categories have different features, different strengths of features in the prosodic features and semantic features. So basically, some poems are better classified by the words they're using, and others, some categories are better defined by the words they're using, and others are better defined by the prosody they're using. So there are differences in such cases, and we know that which ones correspond to which cases. Then from this figure, we're going to investigate that. So you can say that for example, for limerick, we can say that it basically approaches around 97% accuracy in semantic and 98% accuracy in prosodic. Then if we subtract 97% to 98%, it could be minus 1%. This will be a difference for limerick. And we can also do the same for the ballads. It will be something like 95% in semantic, but only about 85% in prosodic. Then it will be a 0.1. There will be 10% difference. So we're going to get 27 such data points. Then we investigate the distribution of that, and we find that. So we can find out this is the distribution of the semantic accuracy minus prosodic accuracy, the difference between semantic accuracy and prosodic accuracy for each category. And we can find out this is basically a left-skewed unimodal pattern. There's only one model in the distribution, that is around between 0.1 and 0.15 difference in such accuracies. So Hartigan's deep test fails to reject. So it actually confirms our observation from this this histogram. We find that the Hartigan's deep test fails to reject the null hypothesis of unimodality, that is suggesting a distribution as a single peak, that there's only one peak in distribution rather than there are multiple peaks. However, we would expect there would be a bimodal distribution if there's a clear division between categories that are more driven by semantic features and those more driven by prosodic features. What does this mean? So if we can say that if there are certain poetry categories that are clearly classified, defined by the prosody they are using, but not by the word they're using, then we will expect there will be a big peak that's in the left. And if there are other poems that are clearly defined by the words they're using, but not by the prosody they're using, then we're going to expect there will be a peak in the right. Then there will be 2 such peaks. So basically, that some poems are better defined, are clearly defined by the prosodies, but not by the words, and other poems clearly defined by the words, but not prosody. Then there will be 2 clear division in the distribution. There will be 2 peaks in the distribution, but this is not the case here. In reality, there's only one. There's a unimodal distribution with only one peak, not the 2 peaks. So it shows us that there's no clear division between the categories defined by the semantic features and by the prosodic features. Rather, it will more be the case that all poems have certain semantic features and certain prosodic features. There'll be a mixture of semantic and prosodic features, and there will be a spectrum of such cases, and different poetry categories has a stronger semantic features, and some has stronger prosodic features, but there will be a mixture for each case. There will be a different proportion of mixtures, and then that's distributed around the entire spectrum rather than clustered to two clearly divided peaks. And then we finally have conduct some experiments to classify poems of different poets. So interestingly, somehow counterintuitively, there's an absence of a correlation between number of pages on and one author has in the Norton orthology and accuracies. So the Norton orthology, we use that to estimate how canonical that poet is. And we find that there's no clear relationship between the strings of semantic prosodic features and or prosodic features, the accuracy of that, and how canonical the poet is. So we can say that some canonical authors like William Shakespeare and Edmund Spenser, they appear in the top right. So they can be very well classified by both prosodic features and semantic features. So meaning that Spenser and Shakespeare basically set the norm for what a poetry category is. However, it is not necessarily the case for all canonical poets. You can say that John Milton, also a very prominent English poet, he appears in the bottom left, meaning that his poems cannot be very well classified by either prosodic features or semantic features. Also, could be different cases for different poets, like Christopher Marlowe, another significant early modern English poet. He can be very well classified by the prosody he's using, but not by the words he's using, the semantic that he's using. On the other hand, like John Kai's famous romantic poets, he can be better classified by the words they're using, but not necessarily very well. Or maybe let's say Philip Sidney, rather in the bottom right, he can be better classified by the words he's using, but not by the prosody he's using. So there are various patterns. So then there's no statistical significant correlation in any of the cases. So the evidence is clear that the strengths of semantic prosodic characteristics are primarily associated with the specific poetry categories, but are not by the author canonicity. So it is not the case that the famous or the canonical authors can either be classified by prosodic features or the semantic features compared to others, but rather that category that matters much more in this project, in this story. The only clear pattern can be observed in the figure is that the translated works are classified with significantly lower accuracy by the prosodic classifier. So we can say that all the most translated works are distributed in the bottom of the figure. So some can be very well classified by the words they're using, showing a high semantic accuracy, and some are better classified, can be very poorly classified by the semantic accuracy, the words they're using. But all of them mostly can be very poorly classified by the prosody they're using. This is very understandable, since when we translate a poem, let's say from French to English, the meters and the rhyme and the prosodic patterns can be easily lost in such cases, so that these poems cannot be very well classified by the prosodic features. But this is only quite intuitive, and not surprising at all. This is the pattern, the only significant pattern that is observable, but not the poetic canonicity. So we can find that we can basically exclude how the canonicity is coming into play in this project, and it is not really the canonicity of the poets, but rather the different features, different poems, different poetic categories that matters in the prosodic and semantic accuracy. And finally, conclusion. For this project in particular, our conclusion is that the vernacular distinction between genre and form appears to have some basis in fact. So in the vernacular, so we call forms and genres differently in literary history and in how we approach this issue, but they are not vaguely defined. But they're quite vaguely defined. But we find that they have some ground. So we can see that there are clear evidence that some poetic categories are better classified by, better defined, mostly defined by the prosody they're using, so they could be more similar to a form. And other categories, some other categories are better defined by the words they're using, so could be more close to genre. So there are certain there are some differentiations between genre and form of the prosodic and semantic features. However, the distinction between genre and form is less crisp than our reliance on separate words has often suggested. So it's not the case that some poetic categories are clearly genres and some poetic categories are clearly forms, or in the other words, so categories with a prosodic or formal characters shade relatively smoothly into those organized around theme or semantics. So in other words, our evidence show that so categories have is a mixture of prosodic or formal character and theme of semantic characteristics. So they shade relatively smoothly into each other. So it's not the case that there will be, as I mentioned in the Hartigan deep test, so not the case that there are bimodal two peaks in the distribution. It's only one peak. So each poetic category has is a mixture of such two, is a combination of such two features, and they each have a certain each category is defined by both the words they're using and the prosody they're using, and there's no clearly boundary like we would imagine that some are clearly genres and others are clearly forms. So this project represents a step towards quantitatively disentangling the formal and semantic aspects of genre. So we hope that it will cast light on the connection between the transformation of poetic forms and cultural narratives. So we hope it could shed light on disentangling semantic and prosodic features and could help us better understand the forms, the formats, the genres, the categories are different ways of defining poetic categories. So we confirm our hypothesis that some poems, some categories like sonnets are better classified by the prosody they're using, but most poetic categories are better defined by the words they're using, but they are not clearly separated. Rather, they will be shaped smoothly into one another. And if we move beyond this particular project and to the larger picture, we find that we'll have some conclusion on the larger picture of computational models and objectivity. So we find that so we have quote my advisor and also my co-author Ted Underwood's point that numbers don't inherently promise objectivity. Rather, that are signs invented by human beings to reason about differences of degree. So in our case, we are not using the machine learning models to reach a conclusion or objectives in our natural law of what is the genre and what is the form, the objective definition of genre and forms. Rather, we try to analyze the subjectivity, to analyze that how people understand. So how when we tag a poem with certain genre and certain poems with forms, what are we really talking about? So we are isolating and examining a certain perspective for poetry and examine them in that particular dimension. So that's how computational models can analyze it with a much larger scope, but also we are not analyzing it we're not trying to reach an objective conclusion, but really understand what human perception are on poetic category and what are the literary history are, and cast new insight into literary history. So we argue that computational methods do not generate an objective oracle, but they enable us to address existing questions and to explore new ones, both beyond the street light. So we can have a new street light that help us to find keys in where we really lost it, to understand the literary history with new evidence, with a larger scope of evidence, with the help of the computational method. We are analyzing around 40,000 poems in total, rather than dealing with 5 or 10 case studies. So I'll conclude this with Alan Liu's quotation in Where's the Cultural Criticism in Digital Humanities, that the humanities are needed alongside the sciences to solve the intricately interwoven natural, technological, economic, social, and political and cultural problems in the global age. So the science are needed alongside humanity. We can combine them and analyze the questions from a novel perspective, and that's how digital math matters in this new landscape. And that concludes my presentation. Thank you very much. And you can see that the full paper of the project presented is openly accessible when in digital humanities, in the digital scholarship in the Humanities Journal, and you can access it without having to subscribe. And you can see what exactly we have done in the experiments. And please feel free to follow up with questions both now or to my email after the presentation. Thank you.
Thank you very much, Dr. Shang. It was absolutely wonderful, and I really like that you shed light at this, myth of pure objectivity, mostly associated to digital humanities. But you show that it's not the case. It's just, we try to find more new questions, like tangible ones, rather than, just stirring and all those things that we used to do. So if anyone else has any question, you can ask or type in the chat box, please. And also, I think this would, pave the way for more cross-lingual research as well, like in other languages. Like, I don't know, if we map, let's say, the Russian poetry, Persian poetry, all the poetry, Chinese poetry all around the world, it could be just, one massive classification. And this would, again, pave the way for cultural studies. So what about, do you have any insight on that or about the possibilities in the future?
Oh, yes, that's a great question. So I mentioned earlier that in the beginning of this part, there's a previous finding that called semantic halo of the meter. So in that particular project, I think it's Dr. Artem Shila from he works with Czech Institute of Literature. I'm not sure exactly where he works, but in that project, he investigated a large collection of poems, of European poems across linguistic boundaries, and analyzed I think Russian, English, German, and poems. And he find that there's semantic halo in all these cases. So for poems across different language boundaries, so the meters they're using and the words they're using are associated. I think we can also do exactly the same thing for our project. We try to classify poems other than the English poems to say that if there is a clear divisions, or I would expect to be the case, will be a clear division. I would expect the conclusion of this project to be applicable to other poems as well. We will find, but there will be definitely a possibility for the next for the future direction to investigate different poems across linguistic boundaries. And also, as you mentioned, Max, that we can analyze the poems across. We can conduct a multilingual research. If we can analyze poems across different languages in all together, but there will be pose more challenges, like different poems will define. They will have a different definition of the of what the prosody are, what are important things are. For example, in Chinese poems, so it will in English poems, for example, the feet are the most important thing. So whether it's iambic or whether iambic pentameter, iambic tetrameter, or Chorchi tetrameter. But in Chinese poems, it's a rhyme that matters the most. So we're going to have a different definition of the prosody here, but we will still be able to analyze whether we will observe whether there's a pattern across the poetry, across linguistic boundary or not. This will be a very ambitious project, and yet, and I would say that Persian will be definitely an interesting addition to that. That's a rich collection of poems.
And there will be something like, I guess, like universal, like UD, that could be, taxes, so you can, all the poems could be tagged with something which could, furthermore be analyzed together. So that all these different collections of, let's say, poetry that we have, or maybe they have been tagged with some features, okay, but necessarily they can't be compared, as you mentioned.
Yes, exactly.
Great. So I think we don't have any. Yep. So I left a comment. Your presentation did not just inform; it inspired as well. Thank you.
Thank you. Thanks for this kind words.
So I also have another question, if possible. So yeah, we have another question for Nikki. So does this classification consist of more relative modern poems, poetry, or just the canons? Like, do we have like only analyzing, classifying canonical or the words that have canonicity, or no, just other poems, new forms, epithets? I don't know, 21st century poetry as well.
That is also a great question. So I mentioned in the data collection part that we use the collection from the tagging of Chadwick Haley literary collections. So basically, for sure, well, the number of 38,000 English poems is a large number compared to traditional method that would analyze a small sample of cases. But of course, they are all somehow canonical. So they're not necessarily always by Shakespeare or Milton, but they would still be somehow canonical to be included in the literary collection. So yes, so there's a great point that if we can incorporate, like say, what Franco Moretti, the important figure in digital math, called the slaughterhouse of literature, the great unread. So because there's a canonical poems will be only consist of very small proportion of the entire literary history. If we can include the great unread, it will be better for us to understand what is going on. But we are, yes, in this case, we're still analyzing the somehow canonical. We're just analyzing a large collection of canonical poems, rather than we can focus on the there are some modern poems, there are some like 20th century poems in our collection, but they're not like the ordinary poems composed by everyday composition activities of ordinary people, but they're still canonical. But it would be great if we can really analyze the great unread to understand the larger picture. But it would be also very challenging to collect these poems, because if they are not canonical, they may not be easy to collect. But we can maybe, for example, we can collect all poems published in certain cases, but there will also be copyright issues, so it will be a challenging problems. So in this case, we're analyzing the canonical poems, a larger, a broader definition of canons. But yes, could be a future step to analyze, to extend the scope to the non-canonical poems.
Great. We have another question by Parsa. So can we also apply this research to novels and plays? Therefore,
yes,
sure.
Yes, I think so. It will be a little bit different, because actually, so I think the analysis of novels of fictions is very represented in digital humanities, and but also for plays, there will be like I find works by Mark R. Hewitt to analyze the English plays, the stages from Shakespeare to 19th century, using network analysis. So this research may not be directly applicable to novels and plays, because unlike poems, we're using prosody here. There's no direct equivalent of prosody in fictions or plays, but there are definitely some formal elements. So we're basically going to convert that rather than prosodic and semantic features to like what words are used in certain plays and novels, and what formal elements are there. There will be not prosody like poetry, but there will be something like how many acts are there in the plays and how many characters are there, something like that. Then we're going to analyze the interplays between the different forms and say what are the formal elements of how are they related to the prosodic, to the semantic or the words they're using. I think the broad idea of this project can be applicable to novels and plays, but we're going to significantly revise the research design because there's no prosody available.
So like we need other measurable factors as well. So maybe we can include, instead of prosody, we can analyze the narrative, like how the whole story is set.
Yes, probably. Yeah.
Great. And also I had a question. So is there possibility of introducing more features, or are we just limited to prosody and semantics? Like if we, have more eclectic and maybe compare 4 features. So is there any possibility of that?
Oh yes, so that's also a great point. So especially with the new development of the natural language processing technique. So basically, what we're defining semantic features here is quite simple. We're just using the word frequency count. But we can also, for example, we can use BERT model to convert the poems into semantic embeddings. So rather than the number of word count, we can convert the poems into vectors that capture the context, and the contextual embeddings, and will be another representation, could be more powerful representation of the semantic meanings here. And also for the prosody, there could be other definitions, like for example, we can use number of lines and how many enjambments are there, for example, so on and so forth. We can go beyond the definition here. And yes, there are many features here. And for example, other things like we can use when the poem is composed, and whether it's that if we're going to follow your question earlier, which language are you using and for that which publication place they were, and we can definitely introduce other dimensions.
So like the more metadata we collect, the more nuance that work gets, or the project.
Yes, exactly. Yeah.
Great. Okay. So thank you very much again, Dr. Shang. It was very illuminating and informative as well. So if you don't have any question, we can call the day and finish the lecture.
Yes, and please feel free to follow up. You will have my email address.
Yes. One more time to the last page. Yep. Great.
Okay.
So thank you, and I'd like to thank everyone, the attendees as well. Have a great rest of your day, and take care.
Bye.
Goodbye.